introduction to Kubernetes, why Kubernetes, and understand the main Kubernetes components: node, pod, services, config map, secrets, and deployment. In order to bring up any application, right, we require all these Kubernetes resources. In order to practice on AKS cluster, what I advise is to install a Minikube cluster on your laptop. If you wanted to check the node, how many nodes are present, what you could do is kubectl get type node. You would be able to see kubectl get node. So there is a one single node is present. If you wanted to see how many pods are running, okay, you will say kubectl get pods. If you see, it says no resources found in default namespace. kubectl run nginx. Nginx is the name of the pod you are trying to give it. Okay, I don't want to give a namespace as that. This is the name of a nginx, so I will say beginner nginx, and I will pass the image name. If I say that, what it will do is it says a pod beginner nginx has been created. So let us go and check it. Okay, if I say kubectl get pod, you will see my nginx has been deployed and it is running. Okay, the name whatever I gave, it is what it is displaying over here. This image nginx is there, right? So it is, what it does is, if you won't mention a version, it will go to Docker Hub and gets a latest one. Okay, this image resides in a Docker Hub. So if you search nginx, this is the one. It will go and download this particular version. So that is the latest. Okay, so you wanted to see it, what exactly it has been mentioned over here. I will say kubectl describe is used to describe your pod. PO stand for a pod. I will say that pod name. The image is this one. At this particular nginx, it has been picked up. The status, it will show you whether it is running or not. Get the pod, right? Here it will say 1 of 1 is ready. Okay. The first is the name of our pod. Okay. Second one is whether how many containers inside it is running. Okay. It is currently one pod has one container. This nginx pod, this pod has a one nginx container running. Okay. The status, the name itself suggests it's a whether it's running, failed, those bit it will mention it out. Okay. If due to some reason it gets restarted, right, that is what it will display over here. Okay. So currently the age of this particular pod is 2 minutes 3 seconds. This is the details about our nginx it is running. So think that you wanted to download your own version of nginx. Few of the application I have installed it. This is our beginner academy versions. Okay, so I will choose 1.4. I wanted to deploy my own image which is present in Docker Hub. The command what I use is kubectl run ba pod. Okay, and then minus image equals to beginner academy ba minus nginx. Okay, I'll mention the port. So I've given a port it as 80. What I have mentioned is this ba pod has to be running on a port 80. So if you see, the ba pod has been created. How do I check it? I will say git kubectl get po or pod or pods. It will show me ba pod has been running from 24 seconds. So now I wanted to access it, what exactly it is there. So for that, what we do is we will run a command called as a expose. What this expose does is it creates a service for us. So if you see here, I will say kubectl get the service. Okay. If you say get service, there are these many services are present. Services you can do via service as well as svc. Short command is svc. If you run this, you will see all the service present. Command, expose command, what it does is it creates a service for us. I wanted to expose my pod, okay, which is ba pod. I will say expose pod ba. Our ba pod has been exposed. Okay. If I do get svc again, you will see a service that has been created. Before that, only 3 were there. Now the ba pod, it has been created. Age, you can see 6 seconds. You wanted to access your pod. Accessing of a pod, it is always done by a service itself. So now I wanted to access my application, which just now I have deployed. I'll say port forward. Yeah, I could have run as is like this. Port forward. I'll say svc and a pod. This is application is running on 80. I'll say 7080. This is my port which will interact with 80 port. Enter. A port forward is a creating a tunnel that is from my local laptop that is on this port. Whatever request I will do it, right, it will forward it to service service will forward it to the pod. In that chain, it will happen. So let me go and access my application now. I will say the port which I gave 7080. So let me say 7080. Let me remove the, so let me access it. So if you see, it said welcome to demo session. If you guys can see, this is the container running inside my Minikube pod. If I wanted to see it, it's basically kubectl get pod. I wanted to check the logs. Logs minus f pod is our gate pod. Okay, I will enter it. I will show you directly. So I have entered it so many. So I will refresh it. If I refresh it, you would be able to see a request. Okay, so I will maximize this bit. Okay. So meaning the request is served by our container itself. Okay, I have done a logging inside the container. Okay, I'll do refresh. So if you see, an entry has been made. Okay, meaning our application is responding. Okay, if you like this particular session, just hit the like button or add a comment. Okay, that would be much appreciated. Thank you very much. What is Kubernetes? It is a #1 orchestration tool. It's a open source, it's free, so it is being used deploying and scaling. When I say scaling, right, you have a less load currently. Application or your project becomes very popular and many people try to access it. Sustain the load, right, you need to scale your application. Meaning earlier, if it was a 1 virtual machine, if it is running, you need to make it as a 10 because the load has increased. You don't want your application to be slowed down. So that is the reason we scale it, meaning we increase your in number of instances of same application to multiples so that it can withstand the load. A little bit background about Kubernetes. So Kubernetes was open source around 2015, but it was built by Google. So its predecessor in Google was Borg. So that is literally battle tested over the decades in Google. So Google was extensively testing on the Borg system. So when Docker became a popular, right? So obviously in order to orchestrate, meaning in order to maintain the life cycle of our deployments, our application, right? In order to make sure our deployment is successful, auto scaling it will happen or not. So in order to do that regular activities, we required one orchestration tool. So Google was already has built this its successor was a Borg system. Okay, it was battle tested. It had all the features. Okay, so it was up and running when Google was using the Borg system from beginning. It has all the features. So around 2015, because of Docker became so much popular, right? Many people started moving to containerization. So during that time, what Google thought was, let us open source it. Okay. So what they did was they got few of the engineers who worked on the Borg system, and what is the bare minimum required in order to orchestrate the containers, right? So those are all the features. What they did was a lift and shift. They did it and created a project called as a Kubernetes. So that Kubernetes in 2015, Google made it as an open source. Because it was already battle tested, it had all the features, all the community was able to adopt Kubernetes. Docker had its own another product for a orchestration of a containers called as a Docker Swarm, but they were building it from the scratch. Okay, the features were not at all ready and it wasn't up to the mark. Google, when it outsourced the Kubernetes, right? So it is a survival of the fittest. Kubernetes, all the features, it was able to thrive. Whereas the Docker Swarm, it slowly died down. Why it became a popular was it had all the history of Borg system, right? So all the features were already in this Kubernetes. If you wanted to scale it or increase the replica set to 3 or 10 or 100, it can do it immediately and you can predict it. So on the fly, with a change of one application, you can scale it out. The name itself, it is originates from the Greek word helmsman or a pilot. We sometimes call it as a K8s as well. A is from the first letter and the other are 8 letters. And next one is a yes. Someone asks you, do you know K8s? So it is nothing but, do you know Kubernetes? Why Kubernetes? Naming and discovery of service was a bit easier. Okay. So you wanted to have a load balancer with a few configuration. With the service, you can enable your own load balancing. Okay. You can have your application health, auto healing part or horizontal scaling. You can do that. Okay. Mounting is also easy, and in order to store your credentials, you can use secrets. Okay, if you wanted to keep in any configuration, we have already a config map already available. Okay, So in order to triage your application, Kubernetes logs, you can check your logs inside the container as well. Kubernetes, you can deploy Kubernetes on any physical server, virtual machine, public cloud, private, or the data center, or on your laptop. Okay. It is bit extensible. In say 10 years back, if there was any issue of our application, right? Application is deployed, and due to some reason, due to space issue or some reason, if application is unable to perform, right, L1 or L2 engineer will be called, and the engineer, if it is whatever the time it is, right, the engineers to go there, fix the issues, and probably restart the application itself. Whenever it has been called, during that time, there is a outage will be there, right, and the person has to be called in. Okay. So due to whatever the issue of the application, though he is doing a manual restart itself, then also the person has to go and log into the virtual machine and do the needful. Okay. But in Kubernetes, you can configure it. If there is any issue, automatically pod, it will get auto restart. Okay. Or if there is a scaling issue is there, when there is a hell lot of load, depending on that one, you can auto scale it as well. These are all advantage of Kubernetes. Heart and soul of our Kubernetes is our APIs. Okay? API controller. In that one, whatever the request it is coming to Kubernetes, it goes to API controller. Depending on the request, what API controller does is, it will send a request to either scheduler, config manager, or a cloud control manager. Depending on the request, it will go in. It will send the request and get the work done. Okay. So etcd is a database. Most of the time, in say probably in 2008, 18 and all, so we may need to deploy our own Kubernetes cluster. That was a bit difficult as well as in order to maintain all these API servers, backup you need to take, or if you wanted a node, you need to go and manually add it. Those all the extra headaches were there. Okay, in approximately 2018, right? So then each of these cloud providers, CSPs, they came up with their own version of Kubernetes service. Amazon came up with their own EKS. Azure came up with the EKS. GKE, Google came up with the GKE, Google Kubernetes Engine. OCI came up with OKE. It stands for Oracle Kubernetes Engine. Kubernetes, we have a control plane, and second one is a nodes. Any containers we run it, right? So we send a request to API controller. API controller, what it does is, it selects a node. A node is you can think of it as a virtual machine. Okay, inside that one, a container will be running it. Because of popularity of Kubernetes, so everyone started selling their own services. All this admin control headache, they have taken care of it. You need not manage API server, database. You need not take a backup of database. So these all the things is controlled by service provider itself. The node also, you need not patch it. You need not bothered about any of the installation. If you want another node, you just send with a couple of configuration change, you can go for another node itself if you wanted to increase the nodes. In this control plane, actual workloads, that is our application, right? It won't be installed on a control plane. It will be installed on a pod. The containers what we run is inside the node. Okay, you can think of our containers as a parasite, which will depend on this node's resources in order to run our containers. What you need to remember is, our containers which we are running, right, it will be running on our nodes itself. The request will be forwarded to API controller. API control will facilitate which node has a capacity, and the containers will go and create it over there. Kube API server, it's a component. It exposes the API. Basically, it's a front end for our Kubernetes cluster. Whatever request we sends it. Any small command, if I say create this particular container, okay, the request will be gone to our API server. That itself, it will create the next step. etcd is a database. Okay, whatever these bits are there, right? So as I said earlier, if it is only if you're working on a data center Kubernetes cluster, then only you should be bothered about knowing about all this. But as a whole, right, in some of the interviews, people will ask how you take a backup of a etcd, right? In the actual world, you won't be doing it because it is all taken care by the cloud service providers. Okay. But major of the cases, if you wanted to clear any certified Kubernetes administrator, right, during that time, you may need to perform this task. Okay. Or if your Kubernetes cluster is installed on a data center, then only you need to bother about all this terminologies, what exactly it does and all. Okay. This is only for a knowledge sake. It is highly available key value store, meaning our request, whatever request we send it, right, everything it is logged and audited on this particular database. Whatever request we make it, it will be entered in this particular database. Kube Scheduler, it's basically responsible for when you ask Kubernetes that create me this particular pod, it will check the nodes, in which node there is a space is available, okay, where exactly it is full. It will try to find it out, the feasibility where exactly this particular node has to go and sit. So that is the responsibility of our Kube Scheduler. Kube Control Manager, okay, there are 4 types of responsibilities are there. Node controllers, if it is goes down, it will feed back the API server. API server will contact Cloud Control Manager, okay. The job controller, if there are any task, it has to be one of task, it has to be created, right? That will be done by our Kube Control Manager. Kubernetes node, that is a main bit, okay. In that one itself, all our application runs. What is kubelet? It is an agent, automatically runs on the specific node itself. It makes sure that containers are running on inside our pod itself, okay, depending on what the specification we provided inside our pod specification, right? So that it will make sure a kubelet component will make sure that containers are running in the respective pod spec. Kube proxy, it is a network layer, okay. So each depending on in EKS, right? So we have a different types of a container network interface. So the next bit is a container runtime, okay. It is a software. It is responsible for running our container. You could have heard about Docker. Docker is a container runtime engine, okay. That is which is responsible for running the containers. Apart from Docker, Docker has its own competitors as well, okay, Containerd or CRIO. If I ask create one a container, so this is the flow of our running up of our containers, okay. So when I say create a pod, the request is gone to our API server. Then what will happen is API server will send a request. It has to be audited. The request will be written on a etcd. This is a database, okay, Kubernetes database. So it will record it. Our API server will send a request to our schedulers. So once we get the information where exactly that particular node it has to bind which pod, okay. So the request will be for when scheduler will respond to API server. So API server again sends a request or audit it or make an entry into etcd database, okay, saying that okay, this is the pod, it will go and create it there. So then what API server will do is it will send inside our particular node, right? It will go and deploy our pod. In this side is our node, Kubernetes node. So once the request is received by the Kubernetes node, right, it will talk to container runtime, which is running on that particular node itself. It will ask Docker to, in this case, in this example, Kubelet will ask Docker to create a container for us, okay. Once the container is created, then the request will be forwarded to our API server saying that, okay, what is the pod status? It can be failed status, it can be created status, right? So that will be again returned into etcd database saying that, okay, this was the request, okay. Now the pod status is so and so, either it is failed or image pullback error, whatever the error it is there, right? It will be written in the etcd. So in this way, the life cycle of one creation of a pod, okay, these all the things it will happen. What is not? So it is a virtual machine, okay, virtual machine or a physical machine, okay, where our pods runs. A pod is the smallest deployment unit. Inside the pod, right, our container runs. In Docker world, container runs on its own, okay. In the Kubernetes world, container runs inside the pod. On the node, we run the pod, okay. Pod will run on top of our Kubernetes node. So inside the pod, a container will run, okay. So and the nodes will be managed by API controller, our control plane. As I said earlier, pod is the smallest deployment computing unit, okay. It can contain one container or more than one container, okay. So usually we go for normal standard is most of the pods will be running 1 to 1 container. One pod, one container is running, okay. In some of the specific cases, okay, so we will be running a second container inside the pod itself, okay. Each pod will be having its own unique IP, okay. By default, one pod is deployed on a particular namespace. It can communicate it to all the pods inside that particular namespace. In the next session, we will be talking about the YAML deployment, how exactly YAML will be used. Kubernetes service, it's basically grouping of the pods, okay, based on the our selector criteria. Service is a group of number of pods, okay, based on the selection criteria. So this is the example, okay. So if I say services, right? So if someone wants to access Nginx service, this Nginx service I have taken a one naming, okay. So Nginx service, so if you see, it had selector called as a key and value called as a app and proxy, okay. So service is another Kubernetes resource, okay. Here what we will mention, selection criteria for this particular team is it all the pods should have this app equals proxy, okay. So if you see the label, this particular pod has app equals proxy. So this if it is a different version also, okay, here if you see there is no version, meaning latest. If it has a Nginx has a 1.5 version, okay, but the label if it has a same as the service, right? So any request, anyone is accessing this particular service, the request will be forwarded to either this or this. Think that this particular pod is also Nginx service, okay, but its label is proxy 2, it has been mentioned, okay. Then this service, though it is a Nginx service, okay, it has a app equals proxy 2, okay, it's not a proxy, okay. It won't send a request to here, okay. This whatever the request coming from here, it won't send it to this particular pod. The selection criteria has been not met, okay. That is the reason it will send only request to the pods whichever has a label same as our selection criteria.